So in the last segment, we saw how to use this for loop for variable in a list to how does it work and how to use it to solve this problem. So one issue is that in some sense this is still a little bit opaque in the sense that it doesn't tell us how does exactly this looping over all element in a list, how does it work. So what are this variable in a list, what is actually the code executed behind it. So now we are going to go a little bit deeper by showing how to do this in another way by using explicitly an index into this list, and we loop over in a value of integers. So we use this a new syntax called range. So let's first explain the range thing. So we can do this loop over a range for a variable in a range with two value a and b. So a and b have to be integers, and these will execute this body of the loop for every integer value a plus 1, a plus 2, all the way to b minus 1. So the value we have should be less than b. It should never be greater than or equal to b. And the variable var here will be assigned to each of this value and then will be executed. So in fact, if I write range with b is equal a, then this loop will not execute at all. So because we only want to consider all the numbers that are less than b. So this is only one way of writing range. In fact, the syntax for range in Python allows three different ways. We can write range to take a single argument, a single number. So this means that we'll be going over from 0 to 1 all the way to b minus 1. And we've explained this AB syntax. We can also use three values, A, B, and C. So the last value, C, kind of represent the step. So A represent the beginning value, B represent kind of like the ending, except that we don't want to reach the end, so we want to stop before we actually reach the end. And C represent the steps. And C can actually be both greater than 0 and less than 0. C cannot be equal to 0. When C is greater than 0, the value we use, the value that are included in the range will be increasing. So the first one will be a, the second one will be a plus c, until we reach a plus k times c, so that this number is still less than b, but the next one, a plus k plus 1c, will be greater than or equal to b. And when c is less than 0, the value will be decreasing. So we will stop when the value becomes smaller than b. So we will keep going until the value is still greater than b, but the next one will be less than or equal to b. So given that, I want you to predict what will be the output for each of the foreign code. So let's actually do them one by one. So you should think about what you expect and see whether what we have here matches that. So we have 3, 5, 7, 9. So we are incrementing by 2, and we stopped before we reach 11. So if I have 12 here, then 11 will be outputted, but not 13. So I guess another version is we have a negative 2. So what will be the output? We output nothing. And the reason is because when we are using negative, we expect the value to go smaller and smaller until it is smaller. But we already started with a number that's smaller. So actually nothing is included in here. So if I have a negative 11 here, then I go, each time I subtract by 2 until negative 9. And let's just, if we go 3, 3, nothing is outputted because because 3 is already greater than equal to itself, so no number is included. If we do 3, 4, then at a single number, if we remove this, so this should give us 0, 1, 2, 3. So that's how range work. Now, using this range, we can solve the problem by basically going over each element. So now the way we're going over each element is we have an index. So we start from 0, and then we tell Python, I want to look at the zeroth element. And after that, I'll add 1. I say, I want to look at 1st element. So that's how we loop over the list, by using the indices. So another thing I want to explain is that we can use this loop over element in a list to implement the count behavior, counting how many times an element occurs. So here I use the syntax of just a variable in a list. So I can alternatively use the index using range, so it's going to be equivalent. So the way to implement the count behavior is we have a start with the default value, how many times it occurs. So when we start, it occurs 0 times. We haven't seen it yet. And then we loop over all the elements in the list. And if one of them is the same as this value we're looking for, we will increment the counter by 1. So here we are using this slightly different, well, we are using this new syntax, plus equal. This essentially means that count equals count plus 1. So it's because these kind of operations are so common. So a variable equal a variable, then do something to it. Could be plus 1, could be minus 1, could be time 2, and so on. So there's a special syntax by using the operator before this assignment equal sign, which it's just a shorthand for this. So there's really nothing special. It's just a shorthand. So this is how we implement this count behavior. We initialize default value to be 0, and every time we see it, we increment by 1. And when we are done, the variable count CNT will store the number of times this value appears in here. So in addition to this plus equal, we can also use other minus equal, multiply equal, divide equal, mod equal, integer division equal. They essentially mean the same thing. So they're just a shorthand for this.